Who can recall?
Is the media access control?
So media. Media access control. What is that?
It's specific for every net card.
Specifically for NIC cards? Any more specific?
It's a unique number assigned to every piece of hardware that communicates to the internet.
So it's a physical address, right? So it's embedded in our NICs. It's specific to the NICs. They embedded on the NICs. If we have more than NIC in our PCs, then we may have more than one MAC addresses, right? So it's a physical address. How many bits are in this address?
How many?
Bits. In IP address version 4 we have 32 bits. So this MAC address has some architect as well. So how many bits are involved in this architect?
32 bits.
Oh my god. Let's add few more.
64.
Sorry,
128.
128?
Yeah.
We are too generous, man. So 48 bits. This one is a 48 bit address.
I have a MAC address, and it's got letters in it. Is that hexadecimal?
You are unique, man, on this planet.
I am indeed.
Right? So, okay, you brought up a thing. So, what characters are involved in this address? What type of characters are there in 48 bits?
Numbers and numbers. Letter and numbers.
Letters and numbers. So, what we call when there is letters and numbers both? Hexadecimal, right? So it's a hexadecimal. So hexadecimal means from which we can go from 0 to 9 and then
It's A to F. A to F.
A to F. Why not Z? Z is not good. Then we don't like at all. No. So A to F. So 0 to 9 and A to F. Whenever we say hexadecimal, it means these are the characters involved in that. So A 0 to 9, A to F. Wherever we are talking, right now we are talking to MAC address, we are saying it's a hexadecimal address, right? So wherever we will listen hexadecimal, thing is same, 0 to 9 and A to F. These characters will be there. We will be talking about IPv6 and IPv6 built on, again, hexadecimal numbers. So if it's 0 to 9 and A to F, what type of new characters did you see? Right?
It's
Can you give me the example? Should I write down here?
0, 0,
0, 0, and then what's the
Colon.
separation? Colon? Yeah.
1A,
1, 8,
1 A alpha, 1 alpha.
1, 8.
A is an alpha.
Okay.
Oh, okay. So that is
Alright.
7, 9, or colon 7, 9.
1, 8,
7, 9,
7, 9,
colon
yeah,
F0,
F 0,
colon 7F,
7, F,
colon Charlie Bravo.
Charlie Bravo. So, see, how many groups are there? 1, 2, 3, 4, 5, and 6. 6 groups, right? And each group is separated by colon. And in each group we have 2 characters, right? If there are 2 characters, each character represents each digit in hexadecimal address scheme, they have 4 bits in it. Each digit represents 4 bits. Here, each digit represents 4 bits. So these things are standard. As I said, if it's hexadecimal, then they are 0 to 9 and A to F. Period, right? Then, if the address is hexadecimal, then each digit represents 4 bits. And then how many bits should be there? 2 digits, 4, 6, 8, 10, and 12. Altogether there are 12 digits. And each is 4 bits. 12 into 4, up to 8, 12 into 8, 12 into 4,
48.
48. So how many good bits are here?
48 bits.
So we have 12 characters, 12 digits here, right? And each digit represents 4 bits. So 12 into 4, we have 48 bits. As I mentioned here. Anything. Write down any number, no problem. In between, I just took an example from there and he had off on his device. Otherwise, it can be any number in between 0 to 9 and A to F.
So not necessarily.
No, not necessarily. We are just, it's an example. So if this one is the case, first 6 digits and then second 6 digits. The first 6 digits always represents OEM. OEM. And OEM stands for
Original equipment manufacturer.
pardon?
Original equipment manufacturer.
Good. Original equipment manufacturer, right? Represents OEM. OEM is original equipment manufacturer. We need to say vendor. Who is producing those devices? Who is making those devices? The vendor. So the first digit they are always allocated to different vendors. So each vendor has pool of these OEM type addresses, right? The portion of OEMs they already have, they get assigned, right? Then they add these numbers. As in networking, we talked about the first, maybe first octet, two octet, or three octets belongs to network, and the rest belongs to host. So we can identify on the network this device is unique, right? The same in MAC address, the first portion is OEM portion, and that is 6 digits, and the remaining 6 digits get added to that. So wherever we will see this number, if they headed over to Dell will come up. For example, if the same, if it belongs to Dell, for all Dell products will have this first 6 digits. The remaining will be different. And if there is a HP will have these 6 digits differently, separate, unique. And now they will adding up. And then each device within HP or within all around the globe is unique. They are coming up with all on their own starting numbers, and the rest they are adding up. So MAC address, and what we do with this? Why we need this?
To communicate with other devices.
How we get?
It's basically the connector to set up the network, let's say.
In this class we all are human, right? How we can identify each other?
By name.
We have different identity, right? Your name is Abdul Kareem, Darren is there, Salman is there, right? So each and every has separate identity. So this device, the MAC identifies the devices over the network. So it identifies uniquely. So this device is this and this is this. If we are able to identify anyone, then we can send or receive the traffic, or we can do some type of communication. Without identifying anyone, there can't be any type of communication, right? The first thing is identification. There is uniqueness of that guy or any device. If we are sending a letter, if I know the address of the letter, I can send him, right? I cannot throw in the air, right? So I need to identify where this guy lives at, right? So same here. So MAC addresses uniquely identifies the devices over the network. So when traffic gets generated, it passes on to all of the devices one time. And the device that traffic belongs to receive that. And otherwise all other devices rejects. Okay, it doesn't belong to us. The first time. If the traffic is getting generated. I'm taking just an example.
So it's to allow the network to identify a specific device.
Yeah, you can come up like this.
Or it's just a device manufacturer.
No. If this one is unique portion, the first digit, if each Dell has different, HP has different, Lenovo has different, each company is get allocated a pool of these 6 digits separately. Then they, whatever they add, what do you think they will add each and every device the same number, the rest? If that was the case, they will be handed over all 12 digits together. So each company is adjusting to their embedded dual IP address, the MAC addresses to each and every needs of the machines. No, they handed over just the first 3 digits. So it's automatically make the devices unique over the network because HP has different starting numbers, Dell has different starting numbers, Lenovo has different starting numbers. And then when they add, they always keep adding different numbers to their own devices within that company. HP, the first three digits will keep the same. The rest, the HP will keep changing. Dell will keep changing its phone, right? And the Lenovo will keep changing its phone. So within HP, the devices will be unique. We can identify the devices within one company by these numbers. And the whole IP address make this device unique globally.
And what's the other portion? The first portion is good.
Yeah. If you guys will let them know in the interview OEM is good to go. Original equipment manufacturer.
So why is it different? What's the, how is it different from Mac? Is it different IP address particularly?
It's a physical address. Again, we will be there. We have talked about IPv4 addresses ahead of the time. I should mention, usually I discuss in 6th or 7th class, but in this class I came up IP addresses only, right? The reason was there.
That MAC address I gave you was for a Android box. Now I get a service every month, but I only have to give them the last three digits. Why wouldn't he need the first three digits?
So you're getting all the last three digits?
Yeah, all it is he requests the last three digits, and then I get a stream of live TV. Well, why would he need the first three?
Because they know their own companies. First, they know
His product. They know his product.
they know
Well,
their
there's-
because each and every company has this one at this same. If devices are belongs to HP, all HP devices have this number first.
That I understand, but if I have a box made by ABC company and then someone else has a box from XYZ company, and all we're giving him is the last three digits, the two companies, the OEM numbers are going to be different. But how is he supplying the service with just the last three?
The reason is within their own company they know already these numbers. The first three digits they know they belong to, and the other vendors also know which number belongs to which company.
Okay.
If you guys will let them know the last, they know the product. Is it Dell, HP, Lenovo, any ABC, XYZ? If they know the company and you guys will let them know the rest three, they will come up the first ones themselves because they know it's already issued. And if you guys want to see, you guys can search for these. What are the OEMs, right? Mac and S portion for Dell, for HP, for Lenovo, for any company. So guys, last time, all your question, right? I did that. Why Mac and why IP, right? Last time we created two virtual machines and we tried to let them communicate with each other, right? We created folder, did we access or not? No? I guess we did or not?
No.
The basic purpose of the devices is sharing, right? The network is to share. And we created machines, but we did not try to access the resources while sitting on other machines, right? If we are having the devices, I have this PC, I have this PC, I have this laptop, I have this tablet, so different devices are there, right? And if they are interconnected like this, or if they are only this one is connected, only these two are connected. And they are sharing the data, right? They are accessing the data sitting on the other devices, right? So we say this one is peer-to-peer. So it's peer-to-peer network. In last class we were discussing LAN, WAN, PAN, MAN, right? Those things. Those are network. When we see them, network is how we see the network, right? That was according to geographical dispersion. How our resources are located, right? Across the globe. Which location those resources belongs to and how we are accessing them. Then that we always say it's a WAN, WAN, those things. But if the resources over here we will see, okay, which device resources belongs to. If devices, each and every device on the network has resources and they keep sharing to each other, it's a peer-to-peer network. But it can be very small networks. If we want to go with this, maybe maximum 10 devices. And if it's more than that, then it start, creating the burden. Administration is then more involved. Then we have to, how can we access the data? If then this PC belongs to LAN, right? And if this is belongs to Soika, so Soika wants to access the resources those that belongs to LAN computer. How he can access the data? What he needs to access the data that is sitting on his computer.
Kind of server.
We are not talking about server. We are saying data is sitting on each and every computer. And if Soika wants to access the data that is belongs to his computer, how can he access?
He has to identify the device. He has to be able to identify the device.
Okay, I got identification done. Then what next? IP address.
Has to be authenticated. Has to be authenticated. Soka is allowed to go online.
That's the point. When we are saying these devices have data, I showed you that it's interconnected. It means they have MAC addresses they already have. We have assigned IP addresses, everything is there, right? So now, how he can, what Soika needs to access the resources? Then his permission. Either LAN is allowing Soika to come and access the resources or not. The first thing is permission, authorization, authentication first. And then authorization. I will be back in 1 minute. Just keep taking.
In class, and I got 3. Fedora.
someone else. And that's the thing I have those, right? And it will take like half an hour to download this.
One song, yeah. A movie would take. A movie would take like real time. You can watch the movie the time it takes to download it.
I never got it downloaded a movie. Oh, this when I started using DSL.
Yeah.
But if they connect you for file sharing, why would you get notifications when you connect them into the network? Because you're supposed to be able to request a file, and automatically goes in one of these and retrieves it and gives it to you.
Yeah, that's a file server. But you have to sign into it. It's all done in the background. You may not have to put in a password, but if your machine is set up to go to that server, and as soon as you sign on to it, if it's part of your network, it's all the authentication, authorization, that's already done. It's already in the background.
You never know these things until you actually play.
I know, but I've been dealing with this stuff like for 40 years at Sears in IT, but I never really knew it just happened. It was in the background, didn't know the mechanics of it.
Exactly.
Now I know the mechanics. Yeah, that's for file sharing. That's like if you're downloading a song, how it comes out in packets. So if you go to one machine and grab a packet, another machine and grab a packet, and then like all the different, PCs around the planet, and pulls it all together and assembles it, and then now you got your song.
So what we do with anything to an abstract, so we can data center, and we quite sure
Not the server. All it did was it goes up to a server and has a list of people that you can drop from. And if their machine is turned on, it would go up there and grab a piece of that song, and it would go to another person, because you have to be uploading as well as downloading.
yeah, that's because when you download the song, right, it says it gives you the source, and the sources are not always the same. They're always different sources.
It's going from this guy's computer to this guy's computer to this guy's computer, taking a piece off here. It just makes it faster. And this also the legality of it. I'm only giving you like a little chunk of data. I'm not giving you a song.
So
listening? No? Permission and authorization. Authentication is permission.
No. Authorization
Is permission.
Is permission, right? User claim permission is here.
Yeah, that's what I said.
I'm saying authentication.
Oh, authentication is,
Yeah. Either the guy who is coming to access the resources is legitimate or not.
he has to confirm the right guy is having access to the right document.
So it's peer-to-peer. The thing is when Soika is coming to access the data on LAN his computer, the first thing computer what will do? This PC has one file that is called SAM. What SAM stands for? Open Google. SAM is database where all the users' names and the passwords stays, right? So if Soika needs to access the resources, first this computer will check either this guy belongs to me or not. Either this guy has, access, any permission, right? So if he does not have his username and password on this file, then will he be able to access anything there? So what do you think? Any random guy can come and log in to the machine? Anyone can go anyone else home without any reason by opening the door and coming, right? No way. Yeah. So there is a SAM file that contains users' names and password that this PC knows these guys belong to me. So if they are coming to them, they will let them come in, right? First thing he needs to access right there. And then what type of permission this guy has? Either this guy has permission to go each and every room of the house, or he is a guest and he should supposed to be stayed in a separate in living room or some place we have dedicated for the guests, right? So according to the permissions, he can move into the computer. Over here, instead of rooms, we have files and folders. So which folder they have access, right? So they can access that. Now, how Soika, without having the account here, access the resources? It's a multi-million question for data.
Password.
Password?
Yes, that have a password.
So he will ask Lanny, can you please give me your credentials? So only Lanny has credentials here, username and password. Either he needs to get the login information of Lanny or
He has to ask her to give him permission.
create an account for him on this PC. So if there is another account we have created for Soika, then he can directly log into the computer. Now computer knows I belong to both of them. Either of them is coming, it's okay for him, right? So they will be able to log in and get the resources. If Lanny will share his username and password login credentials, what it will create? Sulaiman. A security threat, right? They both belongs same company, right? Both belongs to same company, same department. They are working on the same project. Even then, it's a security risk for Lanny. The computer is recording everything and what is recording? Lanny is doing all of these things. Anything happen bad, that goes to Lanny. Whose credentials are being used? Who is logged in there? So in any case, it's a security risk to share the username and password only because we don't share with our family members here, right? So there we are prefer to create another account for them. So we, in this case, if username and password is not a preferred way to, access the shares and resources after sharing these things, no. So we will have to keep creating the user accounts and passwords on this PC. Now, if Omar is here and Omar wants to access the resources, then we need one account for Omar, right? Then if it's a Darren and Darren wants to access the resources, we need one account for Darren here, right? So if we are taking example only of 4 devices here. In the corporate and any business environment, we have a lot of devices, right? Maybe thousands. Can we keep creating those accounts and passwords here? Not possible. So then, here the resources are scattered around the environment. Each PC has something. And to access those resources, we have to create these 4 user accounts here, then 4 users accounts here, then 4 here, again then 4 users account here. So each and every machine will have to create the user accounts. If we have 100 employees, then 100 PCs, on each PC we will have to create 100 user accounts. So peer-to-peer, no more in practice, right? And the next, after peer-to-peer, we have one model for network, that is WooFed. Salman, so what is the client server? Salman, please.
This server has to control. So it's
So as we said, if we have 1, 4, 5, 10 PCs and the resources are sitting on each and every PC, right? Belongs to each and every PC. Here, if we have one server, it's a server. Files and folders are here, right? And now we have So we have these PCs belongs to different guys, right? And we have server there. Now all the resources we decided we will keep on the server, and we will ask these guys to come and access those resources. The first thing what we need to do, what is missing piece in the picture?
Connections.
Connection between the stations.
So first thing is connectivity, right? So these are connections or connectivity. Then what they need?
authentication? You have to have each of those 4 names or more.
So we need all of these user accounts. We have to have on this server as well.
Yes.
So this server should know these guys, so the server will let them come in to access the resources. So we need all of those user accounts. So user accounts on server, all the user accounts. Now what we achieved in this situation, we are not going to create the user and passwords for all 4 of them on these PCs. If we are creating them, then we have to create 16 user accounts on each machine, right? But here 1, 2, 3, 4 accounts there, and then 4 accounts here, 8 accounts altogether, right? So 50% workload gone. So in client and server, resources belongs to server and clients keep accessing them according to their permission. Now, we can say it's as compared to peer-to-peer, it's a centralized administration. So we need to keep the resources at one place. So if we need to back up the resources, we can back up only one server. In peer-to-peer, we had to back up each and every PC separately. The data belongs to all of those pieces. If the data is critical, we always keep backups. So we had to back up for all of those pieces. Now we have to back up only one server as compared to all those pieces. Before we had to create multiple user accounts on each PC, now we are creating at one place. And if we need to remove and add, we can go only while sitting on the one server. And what else we can do? So if it's a centralized, we can add more security there by encrypting the data, by doing bunch of things. We can control the access. Okay, Abdul can come and Renato cannot, right? So Renato can access these folders. Abdul Karim cannot access those folders. So we can go for the permissions in nitty-gritty, right? We can define the permissions better over here in centralized environment. So it's client and server. It's still in we are using nowadays all our client and server environments now, right? We have resources that belongs to some machines and other machines that keep accessing the resources sitting on those machines, right? So when one resources are at the one central place and the rest are keep accessing, it means it's a client server environment. Although our machines are capable to be served as a client and as a server at the same time. Example, if this machine needs to resolve the name, it contacts some DNS server. Please resolve google.com for me. I want to access Google. And that server is serving something to this machine. This one is a client and that DNS server is a server for this guy. But now that server cannot resolve google.com. He needs to access some other servers, root servers, and he is requesting them to resolve the name. And now that server is client for those servers, and that is server for this client, right? So any machine can be a client and server at the same time. Just let me bring that example on the board so it will be clear. I said this PC and we have DNS server here. It's a DNS server. This PC is requesting for name resolution to this DNS server. I want to go it typed only. It's typed in browser google.com. and this name should be resolved first before going to the internet. Here asking DNS, if DNS has a record, it will resolve the name. If DNS have this information within his cache, it will resolve the name. But if this guy cannot resolve the name, he's not going to let PC know, okay, I don't know. Not immediately. He will try his level best. He will search in his database. He will see in his SOS records. So, okay, where I can go. Okay, there are route hints. He will try to go somewhere. And there are a bunch of servers. When we will be discussing DNS, we will discuss these things. And it will get some kind of resolution for google.com. When this guy will get the answer, it will let them know here, right? This PC is a client, and for this client, this one is a server. Is serving to this PC, but for this server, these are the servers, and now here this one is a client, right? Now it's playing the both roles. If it's resolving itself the name, it does not have the second status at this position. Then it's only a server right now. When it starts requesting for resources to others, then it became client as well. So it's a client and server at the same time. So wherever you see, the thing is, whenever we define something, we see something, it depends how we are looking at that thing, right? What perspective I'm looking towards a network. I'm looking towards these machines and the servers, right? So some perspective is there. That perspective changed the whole environment. If we are looking, okay, which machine holds the resources and which machines are accessing those resources, oh, we are talking about client and server environment. Okay, it's a peer-to-peer environment, network. At the same time, we are saying, okay, it's a LAN, local area network. Oh, it's a WAN, wide area network. It's a MAN, metropolitan area network. Then why? What those types are? Now we are looking the network as a geographical dispersion, right? So same, there are a bunch of other things. Then we come to another thing, how those we have established the connections. Right now we just draw a line and we connected them using same wire. Then we say, okay, either we should connect these resources like this, or should I connect them like this? Now our perspective is changed. Now we are looking, okay, how these devices are interconnected with each other, right? When we say like this, then we say, oh, what's the network topology? We come up with a word, what the network topology is, and how they are interconnected with each other. Either we are using just a single wire, we run through a wire through the ceiling, and we just bring some wires from top of that, and then we kept connecting our devices, right? They are connected like this, or we just bring them into a ring. We make a circle for them and connected them to each other, right?
Token ring.
See how simple. they are getting the idea. Salman is way ahead of us, so he kept silent all the time. So then what is this then? If it's like this, bus, so it's a bus topology, right? And it's a ring topology. What's the difference? What's the difference, guys?
The ring would have to go through each machine before it gets to the one that it wants to get to, where the bus can go to almost anything almost in a kind of a direct path. So that one would be like a hub, and that one would be a switch.
Right. So there are, some few connectors are there, right? They are connecting these machines to a single wire, right? So as Darren is saying, we had connected all of the devices with one cable. We run one cable and then we are connecting the devices. What was in real world, it was wire is running through the ceiling and then they draw some wires by using those connectors with different PCs. And we were connecting the PC, right? It was like that. So if it's the case, if this wire gets broken, do we have network then? No. And did we talk about this guy before? Did we? So it's a single point of failure. So we IT guys, whenever we do something, before doing something, we always keep this guy in mind, single point of failure. We need to design a network, we need to plan a network, then we need to implement on that plan and the design. We are going to, bring few systems in the environment, we are on system side. Whatever the scenario is, wherever we are, before moving forward, we keep in mind either it will be a single point of failure for us or no. If no, we are good to go. If that will be a single point of failure, our ears should be stand up, right? Okay, no, you cannot move forward. Only one wire. If there is no this piece, we are going to lose our network, and any piece can be, go down at any time. Any machine can go down. This connector will be, out of order, and this wire can be broken. But if this connector gone, no problem. If this wire gone, only one PC, we are losing the connection. But if this bus wire is gone, then we are losing the whole network. So it's a single point of failure. So then they kept moving onward. They came up with the idea ring topology. Is it easy to install bus topology? Simple, right? So when we design networks, what we see, okay, how much does it cost, right? How expensive it will be? How easy to install or how difficult to install? How easy the administration will be or hard the administration will be, right? What type of bandwidth they will be used, right? How much bandwidth will be required to this network? So different factors are in mind while we are planning or designing the networks. So if we see this, if a single point of failure, otherwise everything rest is okay, we are good to go, right? Easy to install, easy to manage, easy to look around. If we need to see, okay, this PC is not getting the traffic, what I need to do? I need to check here. If traffic is coming up to this connector, it means my network is good. Something is wrong with this connector. Very simple, easy to troubleshoot. There is no much science involved, right? And here in token topology, they came up with this idea. If this link is broken, these machines are gone, but these might be working for some while, right? But again, we have single point of failure here as well. These wires are itself single point of failure. Over here, troubleshooting is easier than the bust problem. We are connecting the devices like this, and if this device is not getting the traffic, something wrong here. Right? In between these two devices, there can be something wrong. So we see the flow of the traffic, where it is going, right? We are losing that flow. So we can figure out. What else topologies we have? These are gone, so we don't need to worry about a lot. Star. What is star? Like this.
This is called mesh.
Right? And each corner we have one device. What you said? What did you say?
Mesh.
Mesh? No, it's a star topology. It's not mesh topology. Star topology, how it looks like. Actually, physical connections are different things, and the traffic flow is a different thing. We saw how logically data is flowing, right? What the data flow is. In physical, we are saying it's a star topology. Is it a physical thing? No. Physical thing is that is a switch, and each and every device is connected to that switch. Can we see the star shape there? No. Can we see the bus shape there? No. Can we see the ring shape there? No. If I am a ring topology, I have two devices here, one device there, one that room, one device is at the receptionist, and we are, connecting them like this. So we are, following this flow. We decided, okay, flow will go like this, from one machine to this machine, then this machine, this machine, and then it will keep moving and will create a loop. Right? So it depends on the flow of the data. We are actually looking at our network, how data is flowing, what the flow control is, how we are controlling our flow. And our flow is saying, okay, we have connected devices like this, so it's a star. Otherwise, maybe we have star topology, but we don't know. There is no star in this room. Wires are not making any star, right? Maybe how we have connected them, data should flow like this. That's a topology, right? So it's a star topology, and it's a logical concept. We can draw a diagram, but physically they are connected like this, but we cannot see them like this. According to the data of flow of the data, we decide it's a star topology. Here we have these devices. These are the interconnected devices. This is connected. This is connected. Why I said it's not a mesh? What is mesh? So it's a star. it means we have multiple links available. More than that, my this device is connected to this, and if this one is goes down, this link goes down, data can still flow, right? And if this link is gone, I have sub alternate for that, so data can choose some other path to go, so data will keep flowing, right? So we have redundancy, some kind of redundancy there. Redundancy means if something goes down, we can still, the things still keep working, the other take over. So we are avoiding here single point of failure. So no fear of single point of failure in this situation in star topology. And in opposite of single point of failure, we always use one word, HA, high availability. I don't know how many put I availability. It's your issue, figure out. It's right or wrong. So high availability. We want our networks highly available. We want our applications highly available. We want our services highly available, right? We don't want, we are big type of Google, www.google.com, and then I write my email, okay, I'm gmail.com, and that's fine. No, you cannot access me. I'm not available. We don't want to see that responses, not in our private life, not in our professional life. So to avoid those responses, those are single point of failures, and high availability we always design our networks and systems like this so they can keep our applications and services running 24/7 without any downtime. There shouldn't be any downtime for our applications. So for those, the most basic thing is connectivity. If we are losing the connections and we are creating the clusters and the load balancing and all other things, everything is useless. Those things are not going to work if we are losing the connection. The first thing we always make redundant, there are our connections, our connectivity. That should be there all the time. On top of that, we can build our environment. If there is no connection, how we can build our environments, right? So in star topologies, we have redundant connections. We are avoiding single point of failure. And my friend Salman is talking about mesh topology. What is mesh topology? If I'm going with the same 5 devices, I'm trying to invent new type of devices. So they have some clouds and those things. Like would be. Each device has connection to other device or not? Or did we miss something?
The one on the left,
So now each device is connected to other device. It's a mesh topology. But if the most expensive solution, we don't go for that at all. We are not going to configure the devices within our LAN, these things, right? Where we are using these topologies, full mesh topology, partial mesh topology, and hub and spoke topology, we are using them for WAN, right? It means we are saying if my one site is in Toronto, so Toronto is my one site, so Mississauga Mississauga is my second site. New York is my third site. Now if I bring them here, Toronto, Mississauga, New York, Washington, or Vancouver. If I'm going to connect each and every site with other sites, how expensive is it will be, right? If to get a line in between sites is not a cheap solution. It's very expensive. And if we are going to connect each and every, we cannot. Only the big government agencies, they cannot afford any type of downtime, any kind of, they want to avoid each and everything for that, they go for that. And we can count them on the fingers on the globe. We don't have much. Full mesh topology, it's very expensive solutions. And then the partial mesh topology, if we remove few of the connections from here, I'm connecting each and every device, but if there are two more critical, I'm giving them direct connections. I'm not going for all of them the full connections, and partial mesh topology is in use nowadays. We are using mesh topology because we are giving each and every device connection, and then the most critical sites we are giving them extra connections, not for all of them. That we say partial mesh topology. So how is spool topology? So like, what's going on, man? Why are you sleeping?
I'm not sleeping.
Actually, really boring.
I'm a bit tired, but I'm not sleeping.
You tired? You did work during the night?
No, I'm not sleeping. I'm writing the notes.
Or did you take nap? You didn't take nap during the night. Anyone? Very nice. You that sounds good?
I didn't nap, I slept.
Is that? What do you think? Did you sleep during the night?
Well, I have the sleepless routine anyways, and it's too complicated to explain. I have the kids, and my wife works early in the morning. I usually wake up every day at 3 o'clock in the morning. And I go to bed at about 11 p.m. So I feel the pain 2 to 3 hours of sleep.
So man, he had good sleep.
How come over the butt all suffering?
What's the reason? There are a bunch of reasons we work, right? no problem. Normal, logical. We have family, maybe some families who, but if some electronics keep us away, then allow me, right? We are watching some shows, we are watching some videos, Netflix is working, right? High demand at our home, then that's a different story. So guys, be attentive and keep me attentive as well. I could sleep only for 1.5 hours. So I'm good. I'm not feeling anything. Mhm. So hub and spoke, when each side keep talking to one central side. We can say it might be a headquarter, and those are all the sites for the same company. Spoke is talking to hub, transferring the data to hub, and whatever the communication is happening in between hub and spoke. How they can talk to each other? They don't need how they will talk
Through the hub.
through the hub. So they will have to come from here. First, we will have to talk to hub and then to the other spoke. So we have more control, flow control. We have more monitoring there. Each and every traffic is going through the hub. Monitoring is there, security is there, central administration is there, easy to administer, right? But the thing is we getting single point of failure avoiding?
If the hub fails, they can't talk to each other.
The most important thing, if this side's gone, the whole network gone. The companies on the ground. Nowhere, no productivity, total downtime. And if this one link is gone,
No,
no problem,
Not big issue.
they can survive.
just for that one spoke is out.
So they have their own things, they have their own things. The only thing, communication gone, but the sites are still working, right? They are working on their own, they are working on their own until the link gets repaired, right? And for in this position, while hub and spoke, we may have redundant connection for most critical sites. For example, we think, okay, this New York site is most critical site. So what we can do, we can add one more link to this. And if we see, okay, this Toronto and this Mississauga site keep talking to each other very friendly, right? So then we can give them one link in exceptional cases, right? If they keep talking and the traffic headquarters is saying, okay, I'm tired of taking care of these guys. These guys are too talkative, right? They keep talking all the time to each other. Let them aside, right? So then we can go another small thing. So whatever we come up with the idea of hub and spoke, full mesh topology, partial mesh topology, star topology, ring topology, bus topology, whatever the topology is, what do you think it's a hard and fast rules? These are just references. These are not references, right? We can live without these things. We can come up with our own ideas, right? So these are all, whatever we discuss, it always these are references, how we can design. These things are help us to design, but these are not hard and fast rules. We cannot deviate, right? We can. With a hub and spoke and I'm adding one connection in between the sides. It's my need. My company requires this. If I want like this, who can stop me, right? So now if I'm adding one connection there, is it a hub and spoke?
Yes.
Can we call hub and spoke anymore?
Yeah.
Again, my choice. I can say, okay, it's a hub and spoke topology. I just added one connection. Right? So everything we study, it just gives us concepts. It helps us to design and plan. But nothing is hard and fast, right? So we can create these things. Right now, coming back to our peer-to-peer and server, client and server, right now we have two VMs, right? And now we are going to add one server in our environment. So it will be the same thing, just the thing is, instead of accessing the data while sitting on two different client machines, we will try to access data sitting on the server. And both machines will access the data at the same time, right? So if we need to do the exercise, we can just will repeat. First access the data from client to client, and then we will add a server, and then we will access the data there, right? The concept is same. So we will add the server, and then what we will have to do, the first thing,
Set up the authentication.
authentication. First, connectivity and connectivity in virtual environments is so simple. We need to connect them to each other using some switch, and we have one switch there already. We are using VM NAT 2. Remember, we have to use the same. Our devices are connected. All of these are connected to the switch. And then we have user account here, admin. So we have admin here as well. Here we will have administrator. And if the account is same, the name is same, for computer is the same account, right? And if I will create just one admin account, both admins will be able to access the data here, right? For machines is the same thing. They know okay, it's the same guy sitting on both machines. Or we can create users here, we can create users here, we can create users, same users here. And then we will gonna have some folder on the server. Folders and files. And we set the permissions for these guys. Who can access, who have full access, who have so read only, or who can just write. What type of these permissions are we will be discussing while doing the lab, right? And the reason to add the server, we could do the same exercise by these two clients. Assuming one is server and one is client. As we said, any device can be a client and a server. The only difference is we install server operating system on high-end computers, right? Who have redundant components. Otherwise, operating system is making their machine a server, and client operating system making these devices a client machines. Otherwise, machines are same, they are behaving same. In servers, we have redundant components. More than one CPU, more than one memory, more than one hard drive, and we can read them together. Any confusion or only confusion? So guys, open your workstation, VMware workstation. So please bring your workstation up. What I did, just double click on this VMware workstation and it should be like this now. Oh, what machines I have here? So these are different, and network. So these machines we have in our environment right now. Client 01 and client 02. We are going to add one server. Just click on home button, home tab. So do we need any break or good to go? If we need break, then we can take right now. So after that I don't want. Take break? Okay, then have 15 minutes break and we will be back at 12:15. Home tab and then click on create a new virtual machine. And then please click on next. And then please the middle option, installer disk image file ISO. Click on that and then click on browse. And then find where you have server 2012 R2. You might have on your E drive or C drive. There should be folder ISOs or software. First try on E drive. On your E drive there will be folder ISOs. And then find one server 2012 R2 there. Oh, I have all 16 now. So like in my case I might have software. Yeah. So any Windows server, Windows 2012 R2 ISO should be there. Got it? Salman? Soika?
Yeah.
Abdul Karim? Everyone got it? Umar? Umar? Got it? LAN heap. So please just double click on it or just click and open. And it should be like this, Windows Server 2012 R2 detected. Are you here? So please click on next and then give it a name. We choose before NT and then just give it a server 01. So NT server 01 and please click on browse and then select your SSD E drive for that. In my case it's a storage E, in your case it's SSD E, and click on make new folder underneath one option and then give the same name NT server. Who is asking something? Yeah, SSD E drive and make a folder there. There is, I just created a folder by clicking here make new folder and then I gave it a name NT server. Everyone done? Abdul Karim? Second Abdul Karim. Abdul Karim with glasses. Just NT server 01. Yeah, good. So it should be the name right one. 01 It doesn't matter, it's just a folder, but we have bunch of machines in the environment, so easy to recognize which machine belongs to which folder. So NT server 01, select this one and it should look like this: e:\/ NT server 01. So next, and then please next, and then customize hardware. Click on customize hardware, and it's already on memory by default. Just move the bar on your right side, right pan, to 4 GB. So installation will be faster. And then click on network adapter here. Just click on it and come to your right side and then click on custom, and then click on drop down arrow and select VMnet 2. And then now we have configured the existing network. We have hooked this. Abdul Karim, where you are? If you will keep swinging on the board and you guys will follow my mouse pointer, you will be good. So now our one network adapter is, Abdul Karim, listen to me, man. One network adapter is connected to VMnet 2, and now we are going to add another network adapter. So click on add, and in your case click on no, and another wizard will open up. So the wizard popped up. Click on network adapter. Inside it, see all of these hardware pieces. We can add any of them. We need another network adapter, so we are choosing network adapter and then next. And now it's asking us, okay, where you want to connect this network adapter. So again custom, and then click on drop down arrow and connect it to VMnet 8 NAT. Click on that, VMnet 8 NAT, and then click on finish and then close. And now please finish. Click on finish. So please click on next, and then click on install now. What is the class rule regarding phone calls? You guys can listen the call but on speaker. So we don't mind calls. So what options are available? These are installation options. We will be moving towards server classes as well. So remember, these are installation options within server 2012 R2. So first one is standard evaluation server core, then server with GUI, and then data center core and data center GUI. Please select the last one, data center evaluation server with GUI, the last option, and then next. We have to accept the license, so check mark for I accept the license terms, and then click on next and choose custom install only, right? Advanced. Click on this, and this screen, the Windows setup screen, give us option to create partitions. We don't need to create any partitions. We can go with default. So click on next. Let it install. So who is doing CompTIA Plus as well?
But,
Oh, good, good, good to know. So Darren will let us know how computer works.
How computer works?
Yeah.
It starts up in the BIOS. It tells the computer, or it looks for a bootable disk, which is usually on the hard drive, and then it finds the file. That file points it to the operating system, which loads into RAM. And once everything's in the RAM, then the computer comes up.
Right. So when computer access the data, we are saying sharing is caring, right? So how then computer works within single computer? Renato.
depending on the software it has.
Right now you guys are doing 901 or 902, or it's
901 so far.
it's a composite class. Composite class. Yeah. Usually it works like that. It's hard to differentiate.
So it works and depends on the software it has.
Hmm.
Or
Salman, good smile. See, now we are going to try either we access the data while data is sitting remotely, right, on other machine. And we are going to do this exercise. But should we don't know how computer work within its own boundary while accessing the data? What the procedure is, how computer works. Actually, what Darren told me, that's how computers boots up, how computers starts up, right? How computer works, he didn't tell me. I'm still waiting for that answer.
Okay, once you got your computer up, you open a program, which goes to your hard drive, dumps it in the RAM, and if RAM is full, it will cache it. You have 3 levels of cache, and just make things fast. It goes from your, it used to be processor to the north bridge to your RAM and back again, back and forth. Processing in RAM, everything's done in RAM. And then the south bridge goes to whatever peripheral devices you may have on your cards. And it does all your operations and then presents it to your screen.
Awesome, good. So computer works like this. So it means Darren is paying full attention in class, right? And he's spending time after that as well. Otherwise, it's not possible. If we know mm, two options, we know the things, we learn the things in class, and then if we are not going through, if we don't know earlier, and we are learning only in the class, and we are not going over the topics in at home, we cannot keep the topics here. So computer, the let supply the password first here. So give it a password, whatever we have assigning out for our class. So W capital WELCOME 1, again WELCOME 1, and then click on finish. Everyone on this screen. So how we can access the login screen? Control Alt Delete. It's written here, right? Control Alt Delete to sign in. How we can send Control Alt Delete command right now through this PC? it's a virtual machine. If it's a physical server, we can simply press Control Alt Delete of our keyboard. The keys belongs to our keyboard. We can send inputs using our keyboard. But here in virtual machine, just this we have talked about earlier. See, where I'm pointing the arrow. This button, click on this button, it will send Control Alt Delete to virtual machine. So click on that, and then whatever we supplied the password, supply here as well. So WELCOME. What you guys did, 2 or 1? See, I did 1. So please remember, whatever you have given the password, remember it. So now it's a Windows Server 2012 R2. So who has installed the virtual machines before this class? Whatever we have done in Network Plus, before Network Plus, who has experience to install the VMs? No one? You have? So what we did in our, when we installed Windows 8.1, the same best practices we are going to do right now. The first thing, when we install any VM in hypervisor, using hypervisor, we need to install the tools related to that hypervisor. Here we are in VMware Workstation, so we need to install the VMware tools on this machine. So please right click on this anti-server one.
A lot of us have a pop-up that says networks. Do you want to find
Yes, click on yes.
Yes.
Yeah. So what they will find out, these 3 machines right now, they can talk to each other and they can talk to their host. So 3 or 4 of the machines, and we want them in a one network. So please right click on this tab for anti-server 01, and the second last option, click on install VMware tools. Now it should pop up in blue message over here anywhere, usually in the most right top corner. If you guys find this, just click on it. Everyone got it? Then please click on run setup 64exe. This is the exe file. Click on this and it will start installing. So please click on next, then please next and install. See what these VMware tools does. First we have very small this window. It will be filled up right according to our display. Click on finish and do yes for restart. Now again we need to click the same button to send, Control Alt Delete, and then give the password whatever you have given first. And see, now it's showing. If I just minimize your, it's a server manager, so click on this and minimize it, and you guys can see valid for 180 days. Why it's showing? We add another network adapter. One, we configured our network adapter for local communication, that was VMnet 2, and the second, that has capability to go online. that can contact these network net plus college routers and can go outside. So it went to online internet and get registered. And these are the evaluation copies we are using, and Microsoft gives 180 days for evaluation in servers. So it's a 6 months for learning software. It's a good enough time, right? So now it gets registered. We don't need that network adapter because we don't want to go outside. We want to see our communication within our own network. Otherwise, we are looking for client 01, and if client 01 is somewhere else and we have something in our cache, it will start looking there instead of here. Just are you here, Abdul Karim? Just minimize this one. It's a server manager. So now please, again, here we have one internet icon. We can, using this, we can go to network and sharing center, or just bring your server manager up, click and it will be up. Click on local server. Under dashboard, the second option, the left side of the screen. Left side of the screen, under dashboard, we have local server option. Follow my mouse pointer. In local server, it gives us option to configure the server. You know, while configuring Windows 8.1, we go at different places to configure. We assign the IP, rename the server. We access those areas using different tools, most of the time control panel. But here, this gives us ease to configure all the things from one place. So see Windows Firewall. First of all, just right click on the hyperlink available for Windows Firewall. Click on this hyperlink, and now we are in Windows Firewall. So please, in your left side, click on turn Windows Firewall on or off, and then choose turn off option for those firewalls, both private network and public network. Choose this option, turn off, do OK, and then please close it. And then what the next? There is one option, IE enhanced security configuration. Click on hyperlink available to that. Are you not installing, Umar Abdul Karim? Went off your PC? Just select for both options, administrator and users off, and do OK. You guys have any install VMware workstation on your those laptops? Those are at home, and then you guys can create these virtual machines. You guys can get the ISOs from here, or you can download simply. These are free. Evaluation copies are free. Just go to the Microsoft Download Center and download the evaluation copies. They are free to use. Just install first VMware Workstation. VMware Workstation, download again, or you guys can get from these PCs you guys have now on your computers here, and install there. The only thing, so guys, please, then see on your left side there is Ethernet 0 and Ethernet 1, right? We have two network adapters, and the server is showing here Ethernet 0 and Ethernet 1. The hyperlink for Ethernet 0, click on that, and it will take us to network connections. Now the Ethernet 1 we don't need. Right click and disable it. And the Ethernet 0 we need that. So just right click and go to properties, and then uncheck the IPv6 second last uncheck, and just simple click on IPv4 and then click on properties, and then click on use the following IP address and give the IP. What we have 192. What IPs we have given? Yeah, 168. 100. Before we have given 1 and 2, 2 or 3. We have given 2 and 3, and now we can use 4. Just tab, click on your keyboard's key tab, and it will be there, the subnet mask, and we are good to go. Just after typing the IP address, hit the key tab, and there will be subnet mask 255.255.255.0, or you can type it. So done. So click OK, close, and now we have given the IP address. See, now we have disabled one Ethernet card, so it's showing only one Ethernet 0, that is active. So click the hyperlink for computer name, and then click on change, and then give it a name, whatever we have labeled it, NT server 01. After typing the name, but after clicking the change, before change there is one spot available to write something, that is description, that is not the name. So click on OK. Saik, are you with us? So do OK and wait for another pop-up. So computer name changes, right? Click OK, and then close this window, and then click on restart now. Without restart, the name will not get changed. No, we are in work group. What happened? So guys, usually we don't wait, right? Being human, most of the time we don't have patience. Without patience, we start clicking. When we click one time, we have given one command to the computer. Let the computer process your command. If you guys will click again, now you will have to wait double time. It will process your 2 clicks and keep adding up. How many how much delay you want, keep clicking on that. It doesn't know why, it's not too sensitive. It can understand this guy is impatient, right? So please, your machine is up. Saika came back. So please click on this button to send Control Alt Delete and just log in. Now it's the time to bring our clients up. So please click on client 01 and then click on power on this virtual machine, and then client 02 and click on power on this virtual machine. So if you guys see this welcome screen, pardon? Then click on this button to send Control Alt Delete and give the password whatever you guys have given for client. And I believe that was welcome too. Then do the same for the second machine. Give the password. So one thing we did not do on our server, that is power options. So it can turn on, turn off after some time, right? So better to do that as well. So if you guys are on your server, please right click on this Windows icon and then click on Control Panel. Then click on System and Security. And then there is Power Options. Click on Power Options. And then click on Choose when to turn off the display. So and bring it to drop down it for never. So if it's changed to never, then save changes and close it. And now on your front on your taskbar there is PowerShell. Just click on this PowerShell one time and ping your rest of the machines. Type ping and the IP address 192.168.100.2. That was our client 1. Are we getting the response? No, unreachable. Why? They're not connected. Why? We put them, all of them, on VMnet 2. Let me double check. So I'm going to client 1 setting. It's VMnet 2. I'm on client 2 and there is settings, and now it's VMnet 2. And if I'm client 1, right click on your Windows icon and open the command prompt, and command prompt admin 1 is good. Click on yes and check the IP address. How we can check the IP address in command line? So ipconfig ipconfig space then slash then all. So it will give us all the configuration of our network cards, including the name and the domain or workgroup. So ipconfig space slash all, enter. So what we have IP address is 192.168.200.2. And I trusted on Salman. So and client 02. Now we can check on client 02 as well. Repeat the same. Right click on Windows icon. Click on command prompt admin. Do yes and type ipconfig ipconfig space slash all. And here we have 100.3, and now we have given our server 100.4. So that machine will be able to our server and then slash forward slash. That is besides the shift key. And then I'm coming back to empty server, and now try to ping the second machine. So ping 192.168.100.3. Now we know the IP address of the second machine. Now it's 128, right? It's getting the reply in TTL 128. So if I just click on your top arrow, we have 4 arrow keys on the keyboard. Click on top one, it will bring the previous command. One time more, we can go to the one time more previous command. So, and using the arrow, come to 100 and change it to 200. Our IP address for the first machine is 200.2. Click and still there is failure, right? So why? We have talked about earlier. What is the reason? Feel free to use speaker, man.
It's not the same IP address. It's not the same.
Better to use the word it's not the same subnet. It's not the same network.
We need to change the 100.
No, we will keep 100 both, but we will keep one machine that is on 200. Our two machines are now 100 and one is 200. So Abdul Kareem, where are you struggling? In typing? So guys, see, this is the command IPCONFIG and then space / all. And if when we ping, we always PING and then IP address. The IP address of the destination machine. So guys, our two machines, NT-client 02 and NT-server 01 are on the same subnet, and the client 01 is on the different subnet. So we need to bring that machine to the same subnet. So please come to your NT-client 01 and then where to go? This internet icon, right click on that, click on network and open network and sharing center. Click on change adapter settings and right click on LAN, go to properties, where are you? Are you here? So right click and properties, and now just select one click on IPv4, simple click, and then click on properties, and now change 200 to 100 and the subnet mask from 255.255 to 3 times 255. So 192.168.100.2 with then it's good. Just it should be like this now. Whatever was before, it's okay. So click OK, close, close and close. And now come back to NT server 01 and now please ping 192.168.100.2 and now we are getting the reply from our first machine 192. So now connectivity is there. Time to live. How much time it will take to keep this information in cache? Right now you guys don't know cache, so I didn't talk about it. 100. No, it's the last. You guys are maybe. I'm clearing the screen and now ping 192.168.100.2. And if you guys need to clear the screen, just CLS type CLS and enter, and it will be clear. So just minimize this PowerShell and now open your file browser on this server. On the taskbar, yellow icon, it's file browser. Just click on it and then double click on C drive and then right click anywhere and come to new and then folder. Cannot see? Where? Just guys, follow the board. I am repeating it. Just click on File Explorer
Oh, down there, okay,
down there on the taskbar,
alright.
and then double click on C drive. Right click anywhere and then come to new, and in front of new there is folder. Click on folder and give it a name. So NT shares, SHARES, shares. Now double click on this NT shares folder, right click anywhere to create a new file inside. So come to new and then the second last option we have text document. Click on that text document and give it a name, NT files. Right now we need one is enough. So on your in search bar, click on C drive and we will be one step back. So now NT shares in first line. Right now it's NT shares. Can we get this using client machine right now without sharing? We have created the folder. So come to your client 02. So open the file explorer on client 02 as well. In your search bar, single click and then type backslash. Again backslash. It's the way we access the resources over the network. So right now if I type the name or server name, where our resources, NT SERVER 01. Can I see anything? Hit enter. No. Just use the right arrow and come in front of we don't have any access first. It's saying Windows cannot access NT server 01.
It says, on mine says enter credentials.
Yeah, because there is no when we say need to access the resources over the network, the resources should be shared resources. The first authorization is the resources where they belong to, the owner of those resources is willing to share, right? Right now the NT server 1 administrators did not share any of its resources. So how we can access those resources? He is not willing to share. So leave it here and now come back to NT server 01 and now right click on this NT shares folder, click on properties, and now we have multiple tabs in this NT shares folder properties, right? So click on sharing tab, click on advanced sharing And now please check mark for share this folder.
I don't have sharing in my permission manager, right?
Pardon?
So you like the general security details and previous versions.
You don't have sharing tab there?
No.
You have only general security previous. Close this one, try again, just right click, anti-share folders,
Oh, so I did something wrong.
click on properties, and now sharing will be there. Did you get it? So guys, anti-shares, just right click, properties, click on sharing tab, and then advanced sharing, and then check this box to share this folder. And then we have permissions, click on permissions, and we are saying everyone please read only. We have only read only permission, right? So click OK, apply, OK, and then again close it. Now this folder is shared. How we can know the path? I just closed it, so I need to come back. So click on properties, sharing, and now we have this one. See, this is the path. What it's saying, so NT shares belongs to NT server 01. So the path will be //. So our NT shares belongs to NT server 01. So we can copy this path from here. Just right click and copy. So close this one and minimize. Don't cancel this screen, just minimize this one. And then right click on Windows icon and click on computer management. Click on computer management. I'm enlarging this window. So there is local users and groups. Click on this, right, double click on users, and then just please a user account. Right click, new user. Give it a name. So user 01, and then password WELCOME02, whatever you guys are giving. WELCOME welcome to. So WELCOME welcome to. And uncheck these box. We don't need to check any box. Make sure all boxes are unchecked. Click on create and create another user account here. Admin, ADMIN, admin. Password welcome 1, welcome 1. Oh, sorry, welcome 2. Whatever we have given earlier. My bad, I go with 1 most of the time. So welcome 2 is our password with blank these options. So create, close. Now we have admin and user 1, and we have admin on our client machines as well. We have that account right there. So come back to NT client 02. Let me access on 1. So it's I have now as I type // the shares pop up, right? Now they have discovered each other. All the machines are now in discovery. So NT shares, if I right click here and double click NT files to open it, can I type something? Yes, very professional writing, I can do it, right? So if I will try to save, can I save? So it's giving another path, so we cannot save the files exactly. So we need to give the permissions so users can work on. Before we just have the user accounts now, so our both accounts we have on our server as well, So our clients can access the resources there, but according to the permissions, and we did not assign the permissions. So please on your anti-server 01, open your file explorer and right click on anti-shares, go to properties, click on security tab, and then see administrators have full access, system has full access, creator has no access here, right? And the user anti-server 01 users have read-only access. We can go by adding those users, or we can go with this a user account as well, and we can just enhance the permissions for this group, the anti-server users group. So I am going to edit this one, and now I can click on users network, the users group, and then click on allow, and it will allow full control, right? So just apply, do okay, okay, and now if I come back to my anti client and I will try to save it, now it's saved, right? So now I have given all the users, what is that users group is? All the user account that we have on server 01 are member of that users group automatically. So we have created two accounts, admin and user 01. They became member of the users of server 01. And now we have given the full permission to that. Okay, I'm coming. So I just clicked now here. Before it was not letting me save, but now I am able to save. And guys, one more thing. Whenever we need assign the permissions anywhere, to get applied is required sign out, log out, and log in. For some reason, for some guys it worked, and sometimes guys it didn't work. But to get applied the permissions, we need to at least log out and log in back. Then it will work. So Shioka, just you can log out the machine, client machine, and log in back.